Welcome to the workshop. We've got just a couple videos left on section 3.5, multivariate distributions. And in this video and the next, we want to consider when we have more than two random variables. So in this video, we'll take a look at three discrete random variables, and in the next, we'll take a look at three continuous random variables. But the main thing that we want to consider in both of these is the fact that what we've looked at in the previous videos for this section apply to exactly this context, three or even more random variables. The only thing that doesn't work out quite so conveniently is our nice visual interpretations or our nice tables. So in the case of the discrete random variables, when we had two, we were able to create a table where on the top margin, we were able to give the different values of, say, the random variable x, and along the left margin, we were able to give the values of the random variable y, and then the table is where, okay, where did those match up, and what's the probabilities of each of those values being taken on. But of course, I can't have a table with three dimensions. I can't write that on a piece of paper, right? I can't have vertical, horizontal, and depth. That doesn't work. So there are some representations. Yeah, you could argue with me if you wanted to, and there we could have a discussion. But for the most part, it's not quite so simple. So for the discrete random variable case, we simply have to come up with a table that rather just lists all of the possibilities for the values of the discrete random variables, and then give the probabilities for those individual cases. So we're going to consider an example that's actually very similar to the one that we looked at towards the beginning of this section, where we consider pulling books off of a shelf. But in this case, we're looking at 4 geometry texts, 2 probability texts, and 2 discrete mathematics texts. So it's some different texts with a different number of them. Right now we have 8. Again, it's 4 geometry, 2 probability, and 2 discrete. Also, we're taking 3 books off of the shelf instead of just 2. And instead of just considering how many geometry and how many probability texts we're pulling off the shelf, we also want to consider the number of discrete mathematics texts that we're taking off the shelf. These things, right, we still would have considered all 3 of these things when we were looking at just the distribution of 2 of them, because that can change what happens for the 2. But here we actually want to be explicit and consider all 3. So let's take a look at this example, which I've already shared quite a bit of. All right. So again, we have 4 geometry texts, 2 probability texts, and 2 discrete math texts. We want to choose 3 texts from the shelf. X is the number of geometry texts, Y is the number of probability, and Z is the number of discrete texts. So this is geometry, and then probability, and then discrete. So X, Y, Z. And in each case, right, 4, 2, 2 are the possible values. That's how many books there are. But I'm only choosing 3 books from the shelf. So what I want to do is I want to find out these triplets that will add up to 3, that of course those numbers can be chosen. So for example, I could choose 0 geometry texts, 2 probability texts, and 1 discrete math text. Or I could choose 0 geometry texts, 1 probability, and 2 discrete. Or I could choose, let's see here, can I do those any other way? Nope, because I can't choose 3 of those or 3 of those. So the next thing that I have is I could choose 1 geometry, and then I could choose, let's see, let's go with 0 probability texts and 2 discrete texts. or I could choose 1 geometry, 2 probability, and 0 discrete. Let's see, I can also choose 1 geometry, 1 probability, and 1 discrete. Now I can choose 2 geometry, 1 probability, and 0 discrete, or 2 geometry, 0 probability, and 1 discrete, or finally 3 geometry, 0 probability, and 0 discrete. So those are the possibilities. And what we do is we actually compute these probabilities the same way that we did in our first example. How many ways are there to do this? And how many ways are there total to pull 3 books off the shelf? So there are, how many ways to choose 0 books of the 4 geometry? Well, 4, choose 0 of them. How many ways to choose 2 of the 2 probability texts? Well, 2, choose 2. And then how many ways to choose 1 of the 2 discrete texts? Well, 2, choose 1. And we're dividing by, there are 8 texts total, so 8, and we're choosing 3. So to divide by 8, choose 3. Okay. 4, choose 0 is 1. 2, choose 2 is 1. 2, choose 1 is 2. So that's 1 times 1 times 2. So that's 2. 8, choose 3 is 56. Of course, I don't expect you to know that off the top of your head. You'd have to either use a calculator or write it out by hand to find that value. That could be simplified if we wanted to 1/28. And then we just complete the rest of the table similarly. So 4, choose 0. 4, choose 1. Sorry, not 4, choose 1 there. 4, choose 0, 2, choose 1, 2, choose 2, divided by 8, choose 3. 1 times 2 times 1 is 2 again, so 2 over 56 is 1/28. And then 4, choose 1, times 2, choose 0, times 2, choose 2, divided by 8, choose 3, is 4 times 1 times 1, 4 over 56, or 1/14. Essentially the same computation here. 4, choose 1, 2, choose 2, 2, choose 0, divided by 8, choose 3, which again is 4 times 1 times 1, so 4 over 56 is 1/14. Let's see here, 4, choose 1, 2, choose 1, 2, choose 1, divided by 8, choose 3. 4 times 2 times 2 gives us 16 over 56, which would simplify to 2/7. And then 4, choose 2, times 2, choose 1, times 2, choose 0, divided by 8, choose 3. That's 6 here. 4, choose 2 is 6. So 6 times 2 is 12, times 1 is still 12. So 12 over 56 is 3/14. This is a similar computation. 4, choose 2, 2, choose 0, 2, choose 1, divided by 8, choose 3, is again 12 out of 56, or 3/14. And then finally, 4, choose 3, times 2, choose 0, times 2, choose 0, divided by 8, choose 3. 4, choose 3 is 4, so 4 times 1 times 1 is 4 over 56, or simply 1/14. All right, so this is the joint probability distribution of X, Y, and Z. It is in a table, yes, but it's not in a table like we saw at the beginning of the section. Let me flip back to that a moment. Let's go back a few pages. Here we are. So it's not a joint probability distribution like we saw here, where we had the possible values of x and the possible values of y. Because we would also have to have the possible values of z, and I can't add that on here. That doesn't make sense for us to do. So go to the end here. There we are. So we get simply the triplets of the possibilities. Excellent. So in terms of extending this idea to the cumulative distribution, or the joint probability distribution function, rather, it still works out the same way. If I want f of x, y, z, that is equal to the probability that x is less than or equal to x, y is less than or equal to y, and then of course with the third variable there, z is less than or equal to z. And if I had 4 variables or 5 variables, it would be the same extension. And then finally, if I want to know if a function can serve as a joint probability distribution, I need all the probabilities to be non-negative, and I need the sum of the probabilities to be 1. If you were to check that here, you would indeed find that the sum is 1. For example, let's see, 1/14, 2/14, 3/14, 7/14, 10/14, 13/14, 14/14, 1. So we do have that, and of course they're all non-negative. So it's the same thing for 3 or more as it was for 2 or essentially even 1. We just have the multiple summations. All right, so in our next video, and the last one for this section, we'll take a look at 3 or more continuous random variables. So I'll see you guys back in the workshop real shortly.